This week we are following up our simple probability with probabilities of compound events. Please keep in mind that the word simple for the last one simply meant one thing happening. It was one choice out of a certain number of probabilities. And so or possibilities. And what's going to be different about today is that we're talking about compound events. That means that more than one thing is going to be happening. So, simply put, for our compound probability, this means that we need to multiply the probabilities. So when I'm trying to do some probability and another probability, that means we're going to be multiplying these numbers. Multiplying for fractions is just straight across. So our answer is going to be whatever we have by the top numbers, the numerators multiplied, and the bottom numbers multiplied for our denominators, and that will make us a new fraction, which will be the answer to our problem. So let's look at this example. You're at a clothing store that dyes your clothes while you wait. You get to pick from 4 pieces of clothing, so here's one choice that's going to be made, and 3 colors, so here's a second choice that is going to be made. So from our simple probability, I know that my chance of getting any one of those 4 different types of clothing would be a 1 out of 4. And I know that the chance of getting one of those 3 colors is going to be 1 color chosen out of 3. So that means that when I multiply these together, 1 times 1 does make 1, 4 times 3 does make 12. So the answer to this problem is the fraction 1/12. Here is a second example, again in the same topic of compound events. If you flip 3 fair coins, what is the probability that you'll get heads in the first 2 flips and tails on the last flip? So once again, keep in mind that we have several different things happening here. It looks like we have 3 individual flips of a coin, and these are all and, which means that we're working for that one particular number at the end, and that and again means we're multiplying each of these probabilities together. So recall, a coin flip will always end up in either heads or tails, which means that we always have one of 2 possible outcomes for each one of these. So I've got, again, several flips of this coin to worry about. So I've got a first one, a second one, and a third one. And for the first 2, we want heads. Well, that's a 1 heads out of 2 sides. And the second one is also a 1 heads out of 2 sides. And the third one, we want tails, but that tails is just 1 out of 2 sides again. So for each of these things happening, this one and this one and this one, heads and tails, we are again multiplying these fractions. Multiplying is again straight across. So across the top of these fractions, all the numerators, 1 times 1 times 1 is a whole 1. And across the bottom, 2 times 2 times 2 is, don't say 6, 2 times 2 is 4 times 2 would make that an 8. So the correct answer to this problem is going to be the fraction 1 out of 8.